So right now we are asked to evaluate the definite integral from 1 to 2 of 4 ln x over x squared with respect to x. So right now let's take a look at what we can do to this integral. So if we look at our integration tools, then we can examine what substitution can do. So if we substitute 1 over x or something, we would still have another 1 over x, so that's not going to be very helpful. If we substitute x squared, we can't get rid of the x inside of the ln, so substitution is out of question. Let's see if we can use integration by parts. So this is indeed a product of two different functions. We can rewrite this as the integral from 1 to 2 of 4 ln x times 1 over x squared dx. So we can try to use integration by parts to solve this. Now, do we want to differentiate ln x, or should we differentiate 1 over x squared? Well, if we differentiate ln x, then we're going to get 1 over x, which might make things simpler. Whereas if we differentiate 1 over x squared, we're going to get larger and larger bases in the bottom, and we're going to have to integrate ln x, which will give us something more complicated. So we're going to not integrate ln x, and we're going to differentiate it instead. So we're going to let u equal 4 ln x, and du is just going to be 4 over x dx. dv is going to be 1 over x squared dx, and v is going to be the integral of this. So that is just going to be negative 1 over x. There's no d's. So if we look at this, if we rewrite this as negative x to the negative 1, we can easily see that if we differentiate this, we get positive 1 over x squared. So right now, we are going to rewrite our integral. So we have, instead of doing the definite integral, I like to write this as the indefinite integral and then evaluate everything at the end. So what we can do here is we can write this as negative 4 over x ln x, and then we are going to subtract v times du, the integral of that. So this is going to be negative 1 over x, du is 4 over x dx. And remember, what I did here was just use the integration by parts formula, which says that if you have the integral of u dv, you can rewrite that as uv minus the integral of v du. So going back to our indefinite integral, we can keep going with this. So negative 4 over x ln x. So these two negative signs just become a positive sign, and we can take the 4 outside. So all we get is the integral of 1 over x squared dx. And as we know, the integral of 1 over x squared dx is just what we already did here. So we can rewrite this as, I don't know why I wrote a 4 there. That's supposed to be an x. We can rewrite this as negative 4 over x ln x plus 4 times negative 1 over x plus c, because this is the indefinite integral. But what we are concerned with is not the indefinite integral, but the definite integral from 1 to 2. So to solve that, all we have to do is plug in our bounds of integration. So what we get here is negative 4 over x ln x, take away 4 over x. I wrote 4 again. 4 over x, and we want to evaluate this at 2 and at 1 and subtract the results. So if we do that, then we should get negative 4 over 2 ln 2 minus 4 over 2 minus the same thing for 1, so negative 4 over 1 ln 1 minus 4 over 1. So we know that ln 1 is 0, so we can just get rid of that. And minus 4 over 1 is just plus 4. So we can simplify these things to negative 2 ln 2, take away 2, plus 4. So our final answer should be 2 minus 2 ln 2.